Hi, I'm Dvorecki from Mobileye. We're developing a new imaging radar for autonomous driving. And in this project, we were very interested in trying to understand what kind of information is contained in the radar point cloud and what type of information can be inferred from environmental cues in the environment. The problem with point cloud data is that it's very difficult to understand for a human. Looking at these kind of point cloud data, it's very difficult to understand the scene. This is in contrast to things like LiDAR point cloud or camera images. So instead, what we did is we took a car together with a camera and a LiDAR, and we trained a neural network to try and transform the radar point cloud into pseudo LiDAR and pseudo camera images of the scene. So given the radar point cloud, the network tries to guess how would a camera see this scene or how would a LiDAR see this scene. This helps us both in understanding what the radar sees as well as trying to understand the typical biases that we have in our training set, where most of the time we see that we're able to very accurately reconstruct the scene. We see here an example of driving in a tunnel where we were able to reconstruct most of the LiDAR information, but it also allows us to understand biases where, for example, infrequent objects such as construction sites that are infrequent in the training set are rendered as different objects. In addition, it allows us to understand which types of objects are easy to detect, such as vegetation and small signs or cars, versus objects that are more difficult to detect. In addition, it allows us to perform all sorts of experiments on the data, such as manipulating the point cloud data, such as to take the generated image and, for example, increase the RCS of all of the moving objects in order to create images of trucks and buses instead of typical vehicles and other different experiments.